Okay, so today what we're going to do is we're going to be talking about algebraic fractions. The good news about algebraic fractions is that they behave just like any other fraction.
Wow.
The bad news about algebraic fractions is that most of you have never learned how to work with fractions well enough to be very comfortable with it. Now, that's not all of you. Some of you are very comfortable with them. So what we're going to do is we are just going to first go over some general ideas and rules about fractions just to remind you. Now, this is the same kind of thing that we did when we did the number section, when we did the fractions. So these notes are going to look exactly the same. The only difference is that instead of just numbers, you're now going to have, what are the building blocks of algebra called? Well, terms, right? So you're going to have letters in there. So you're going to have variables. Good. And also you're going to have to watch out for signs. Especially with fractions, you're going to have to watch for signs. Okay? Because you get wrapped up in the fraction and that causes you some trouble. But are you allowed to use a calculator on this test?
Yes.
Are you allowed to use a calculator when you're doing your work? Yes. Did you know that your calculator can add and subtract and multiply and divide fractions for you?
Really? Yeah.
The number parts, not the variable parts. So if I would rather you do it by hand, because then you gain understanding, and you need to remember that it's difficult. Your calculator can't do all the ones with the algebra in them, but it can do basic fractions. All right? So what I don't want you to do is just give up and not do any of these because you don't like fractions. So that's my goal here. All right, so here we go. The first rules for fractions. And I know you love rules. Guide your life. The first and most basic rule for fractions is that you must simplify or reduce. Is there another New Zealand word for that? When you divide out the things that are common to the numerator and denominator, is that just simplify? Reduce? Okay. So you may hear me say reduce. It means the same thing. Okay? Simplify or reduce. In other words, divide out any factors. Remember, factors mean things that are multiplied together, which is every part of a term is a factor, right? So if you have 4x, that's literally 4 times x, right? So the 4 is a factor and the x is a factor, right? So divide out any factors that are common to both numerator and denominator. Remember, a fraction is a numerator. The top number is the numerator. The bottom number is the denominator. And remember, I always abbreviate those. I told you when we did this before, I'll never spell that out anymore, but I'll never use capital N or capital D for anything else. Numerator is capital N, denominator is capital D. So, just to remind you, so say for example, we have 4 over 6. Is there any number that will divide evenly into 4 and 6 at the same time? 2. Good. So divide 4 by 2 gives you a 2. 6 divided by 2 gives you a 3. Is there anything that will divide evenly into 2 and 3? No. So we know it's completed. The only difference now is that you're going to have more pieces to divide. For example, it could be 6x to the second divided by 8x. So the introduction of the variables doesn't really change anything. You're still just going to look at it piece by piece. Because remember, the fraction bar means to divide, right? So, but I can't divide a 6 by an 8. But is there anything that'll divide into 6 and 8 at the same time? 2, right? So 6 divided by 2 is going to give you a 3 in the top. 8 divided by 2 is going to give you a 4 in the bottom, right? And the next factor in the numerator is an x to the second. Is there an x in the bottom? Yes. Now, here's the key. If they're the same variable, okay, if the same variable occurs in the numerator and denominator, then you can divide out, the smallest one. Now write that down and then let me talk to you about what it means. Because if they're the same variable, that one's not smaller. But what I mean by that is you have fewer factors of it. Okay? So if the same variable occurs where? Numerator and the denominator, then that means you have a common factor. And so you're going to divide away the biggest thing possible, and the biggest thing you can take out of both of them is the smallest one. That's what I mean. So look in this case. I have an x in the top. Do I have an x in the bottom?
Yes.
Yes. In the top, it's an x squared, right? In the bottom, it's just a plain old x. So which one of those is the smaller one? The plain old x, right? That means I can divide both of them by an x. Do you see the logic there? So x squared, if I divide out an x, what's left? Another x, right? X, if I divide x by itself, it's going to divide away. It doesn't cancel. Anytime you divide something by itself, what does it really make? 1, but I already have the 8 there, so do I need the 1? No. So in the top, I'm left with an x, and in the bottom, the x is divided away. So my completed answer is 3x over 4. Okay? Now, and we're going to look at we'll look at some more. But before I do that, I want to talk about notation. That is not the prettiest notation at the end when you're finished. Okay? Just the way you write something. All right? Sorry?
Are we still going with rules for fractions after the notation?
Yes. Okay? For notations, if you have a variable.
What's a notation?
There you go. Thank you. In the numerator only. Okay. So there's a letter in the numerator only, right? So does that mean there can be one in the bottom? No. That doesn't. This only occurs when the numerators when the variables in the numerator only. Then drop it to the side. Let me show. Don't panic. Just let me show you. There's no math involved here. It's just a notation. So instead of 3x over 4, I would write that as 3/4 and then put the x on the side. Okay? In other words, you're separating the number part of the fraction from the variable. Okay? Because 3/4 x literally means 3/4 times x over 1. And if you multiplied those straight across, you would get right back to the 3x over 4. So they mean exactly the same thing. But in algebra, the notation is always specific, right? So if you can make something more simple, then you should. And this is the preferred format. Now, I am not going to count it wrong if you put 3x over 4. But I am going to warn you that as you move forward with your mathematics, that 3x over 4 might cause you some issues later. But you need to recognize that they're the same. Okay? So if I write 2x over 3, 2x over 3 is the same as saying what? 2 over 3x. Do you see it? These two things are interchangeable. Now, this one is the preferred form for an answer, but when you're working, we sometimes like this one. So you need to be flexible enough to be able to do both of them, but for your answers, really, this is the preferred form. Does that mess with you too much? Okay? You'll get used to it if you haven't seen it so much already. Okay? So, let's just do another one where we're dividing out common factors, right? So say we have 16 x to the third, y to the fifth, divided by 8 x, y to the fourth. Doesn't matter how much stuff you have, right? Because you're going to look at each piece individually. Okay? So first, let's do the number. So because the fraction bar means to divide, so we need to divide away anything that we can. So will 16 divide by 8?
Yes.
Yes. So this time, 16 divided by 8 is just going to leave you with what? 2. And it's going to be in the top. Why?
Because
Because the bigger thing was in the top.
Is this how it's work, or is this just like
Just right here, right now. Then we have an x to the third in the top. Is there an x in the bottom? Yes. So there's an x to the third and an x. Which one's the smaller one? X. So that means I can divide them both by an x, right? Well, x to the third, divide out an x, I'm going to be left with what? X squared. X divided by itself is simply going to divide away. So is there going to be any x's left in the bottom? No. Let's go to the next one. Y to the fifth, y to the fourth. Which one's, is there y in the top and the bottom?
Yep.
Which one's the smallest one?
The bottom.
The bottom with y to the fourth. So we can divide by y to the fourth. So do you see, all I'm doing is trying to get you to see that logic that whichever one's the smallest, that's the one you can take out. So y to the fifth divide out y to the fourth is just plain old y, right? Y to the 1 or because you remember what you do when you divide them is subtract the exponents. And then y to the fourth divided by itself turns into a 1. So is there anything left in the bottom?
No.
So do you have a fraction anymore?
No.
And that's perfectly can happen, right? You can start off with a fraction, it can simplify. So there's my answer. Okay. All right. One more. What if you had 3x to the second y divided by 5x to the third a? Looks bad. Does that mean it's hard? No. Nope. Don't worry about it. So first divide the numbers. 3 and 5. Do 3 and 5 have anything in common?
No.
So is it going to change? No, remember, numbers that you can't divide are how fractions are born, right? So it's just going to stay 3 over 5. There's an x in the top one. Is there an x in the bottom?
Yeah.
Yep. In the top, I have x to the second. What that literally means is 2 factors of x, right? X to the second means x times x, so 2 of them multiplied together. In the bottom, I have x to the third. Well, if I have x to the second and x to the third, what's the most I can divide out of each of them? X to the second, right? With the smallest one. So x to the second divided by itself is going to divide away. It really turns into a 1, but since I already have the 3, I don't need the 1, right? X to the third, if I divide out an x, what's left?
X.
I'm sorry, divided by x to the second, I get x left. Now notice it's in the bottom. Why?
Because it's bigger.
That's where most of them were, right? Good. Then the next factor up there is a y. Is there a y in the bottom?
No.
So is the y going to change?
No.
Nope. Then there's an a in the bottom. Is there an a in the top?
No.
So the a stays where?
The bottom.
In the bottom. So sometimes you can divide things away. Sometimes you can't. If you can't, you just leave it where it is in the fraction. Yeah? Looking familiar? So it's not that different, and that's why we spent so much time looking at dividing terms so that when you get to the fractions you can see that the same information still applies. Okay? Now, so that's simplifying fractions. And simplifying fractions is the most basic idea behind fractions, which also means that they're not really going to give you any of those to practice on. But it's important that you understand because you're going to use it in other ways too. Okay? Second thing we're going to do is we're going to talk about the operations with fractions. And again, I'm not writing algebraic fractions because the operations with fractions are the same whether you have algebra or not. Okay? That's the beauty of fractions. The rules don't change. There's just more stuff to look at. And the first one we're going to look at is how to multiply fractions. Now, we talked about this when we did the number, and now it's even more important when we're working, when we're working with the algebraic fractions. There is a primary school method for multiplying fractions that works until you get to this point in your mathematics career. Then it stops working. Now, it'll work on the ones we're working on today because we're talking about just basic fractions, but that's not where we're going to stay, right? So it won't work later. So we need to make sure that you don't use that shortcut. Do y'all know what I'm talking about? When primary school, how were you taught to multiply fractions? Just multiply straight across and then simplify after, right? That will not work in algebra. You have to reverse that process. So the first step is to simplify. And you can even remember the little rhyme, simplify before you multiply. It's the only one where you do that.
It also rhymes and also multiply for you.
Yeah, but don't do that. Okay? Simplify before you multiply. You just needed to rain on my parade, didn't you? It's all right. Okay. So, if you don't simplify first and the fractions are small, no problem. It'll still work as long as you're careful. If you don't simplify first and the fractions are big, good luck getting out of the mess that you create for yourself. Okay? And besides that, do you want to multiply with something that has 5 terms in it? Or would you rather simplify it so that it only has 2 terms in it? You're saving yourself the trouble if you'll simplify first. But remember, when you're multiplying, you're talking about having at least how many fractions? 2, because you can't. If you just have one fraction, you don't have multiply, right? So you can simplify any numerator to any denominator. As long as it's multiplication, it doesn't matter which fraction it comes from. Okay? As long as you're going from numerator to denominator, as long as you're crossing that fraction bar, then you can divide. Okay? So if you have an x in the first fraction and an x in the second fraction, can you divide them? Yes, as long as it's multiplication. Okay? We're going to look at some examples, so don't panic. And then finally, after you've simplified, then you simply multiply straight across. Numerator times numerator, denominator times denominator. And yes, you can replace the dots with x's if you just have to, but it makes me crazy. Okay?
What do you mean simplified and then what is
Any, as long as you're going numerator to denominator, it doesn't matter which fraction it comes from. So say you have a 2 in the first fraction and a 4 in the second fraction. It doesn't matter that they're not in the same fraction. And we'll look at some examples so you can see. Okay? As long as it's multiplication, you can simplify from any fraction. I'll show you. Don't panic. You'll see it in a second. As long as it's numerator to denominator, it doesn't matter which fraction it comes from. Okay? Am I shouting? Okay? All right. So, let me find a good one here. All right. So I'm just gonna pull some from your book. This one's number 2, so it's 7. I'm on page 21. 7z times I hate that over 2z. The most important thing you can ever do with any problem is identify the operation you're dealing with, because if you don't, then you're not going to know how to work, what process to go through, right? What rule to follow. In this case, the operation is multiplication, but I'm multiplying with what kind of numbers? Starts with an F. Fractions. There you go. Good job. Thank you. So you're multiplying with fractions, because you can't just say multiplication, because regular multiplication is not the same as multiplying with fractions, is it? So before I multiply, I first need to see if I can what? Simplify. So just look at every factor. The first factor in the first numerator is a 7. Is there a 7 or anything that will divide by 7 in the bottom? No. So can't change the 7. The next factor in the second numerator is a 2. Is there a 2 or anything that divides by 2 in the bottom? No. Did I try both factors in the numerator? That means nothing's going to simplify because it has to be numerator to denominator. So I'm just going to multiply how? Straight across. So 7 times 2 gives me 14. And z times z is z squared or z squared, whichever you prefer. Sorry. Okay? It's perfectly happy for you to say that. All right? That's an excellent question. Now look at this, guys. What if I have the same exact problem, but it's like this? There's a 7 in the top. Is there anything that divides with 7 in the bottom? No. There's a z in the top. Is there a z in the bottom? Yes. Now that one of them's in the numerator and one's in the denominator, they can be divided away, right?
Really?
Does it matter that they're not in the same fraction?
No.
No, because of this operation, because of multiplication. Now, if it's addition or subtraction, would it matter? Yes. But multiplication is that operation that pretty much lets you do anything. So z and z will both divide by z. So z divided by z is going to leave you a 1. Z divided by z is going to leave you a 1. And then you just multiply how? Straight across. 7 times 1 is 7. 1 times 2 is 2. So do you see the difference? Up here, we just ended up multiplying them together. They couldn't divide away because they're not on opposite sides of the fraction bar.
I have a question.
But down here, they're on opposite sides of the fraction bar, so they were able to divide away. Yes?
If that end result is able to simplify, you simplify that, right?
Well, it should have already been simplified all the way. Yeah. Now, notice that the numerator is bigger than the denominator. Perfectly fine. That's the way I want it. Don't change that to 3.5. Okay? Unless you're answering a word problem. For example, if you say how many hours do we have left in school, 7 over 2 doesn't make much sense, right? But if I change that to 3.5 hours, that makes sense, doesn't it? Yeah. So when you're answering a question that involves units or a word problem or something like that, then yes, a mixed numeral makes sense. But otherwise, in mathematics, never change an improper fraction to a mixed numeral because you'd have to change it back again if you wanted to add, subtract, multiply, or divide with it. Okay? Yes?
You know the square root of 14 over z squared?
Or the exponent, you mean?
Yeah. What? Can't you just put z?
No, because it's a z times another z, which makes z to the second, right?
Yeah.
Remember when you're multiplying? So it's like z to the first times z to the first, which is z to the 1 plus 1, which makes your completed answer z to the second.
Multiply the same numbers, it would be 1 times 1 equals 1.
But that's just what happens with numbers, because you can multiply numbers, but with variables, you have to add the exponents when you multiply them. Okay? All right. Let's look at some more of these. Again, we're just talking about multiplying these. Now, not every time will things divide away, but sometimes they do. Look at this one. So we have 2yz. They always give me z's just so that y'all can give me grief. Times yz squared over 2. Yeah, this is number 8 in your book. So what operation is indicated here? Multiplication. With what kind of numbers? Fractions. There you go. Fractions. So going to our rule for multiplying fractions, before I multiply, I must what? Simplify. And since it's multiplication, that's any numerator to any what? Denominator. So what is the first factor of the first numerator? A 2. Is there a 2 or anything that divides with 2 in the bottom? Yes. So since they're the same, 2 divided by 2 turns into a 1. Guys, come on. But since it turned into a 1, but I still have a y and a z up there, so do I need to write the 1 up at the top? No. But in the bottom, the 2 turns into a 1, and that's all there is, so do I need to write the 1? Yes. So you do need to write the 1 if it's all that's left. Okay? Yeah? But if there's other stuff, you don't worry about it. Then we have a y. The next factor is a y. Is there a y anywhere in the bottom? No. But there's a y in the top of the other one, so can I eliminate that first y with that y? No. Because in order to divide them away, one has to be in the top and the other has to be in the bottom, right? If they're on the same level, then don't divide them away. Then I have a z in the top. Is there a z in the bottom? No. Go to the next one. There's a y. Is there a y in the bottom? No. There's a z. Is there a z in the bottom? No. So now I'm ready to just multiply how? Straight across. Now, I know it's a little messy, but there's no number times no number stays no number, right? What's y times y going to make? Y squared, excellent. What's z times z to the second going to make? Z cubed or z to the third. Yeah, excellent. Okay, and in the bottom, I just have 7 times 1, which is? 7. And there's your answer. Okay? All right. Okay. Now, I want to show you number 10, and I'm not going to do the whole thing. I'm not going to worry about doing the whole thing. What I want to show you about number 10, if you look at number 10, we have 3 times x plus 1 over 2. I guess we should do the whole thing. Times x over 5. What operation is indicated? Multiplication with what kind of things? Fractions. In order to multiply fractions, the first thing I have to do is simplify. And the first factor is a 3. Is there a 3 or anything that divides a 3 in the bottom? No. Okay. The second factor is this bracket. Is there a bracket in the bottom? No. Okay. The next factor is this x. Is there an x in the bottom? No. So nothing will divide away. So what I need to do is just multiply straight across, right? But I have an issue here. I've got to take that bracket times something else, right? So what I need to do first before I can complete the multiplication is get rid of the bracket. Yeah, use the bracket. So 3 times x is 3x. 3 times positive 1 is positive 3. Okay? And then I'll take that times what? So 3x times x is
3x squared.
Excellent. Positive 3 times x is
3x.
Positive 3x maybe, right? You have to have a sign. And in the bottom, 2 times 5 is? And there you go. Now, in the back, they may not have multiplied out that bracket. If they didn't, then it's just the 3 times the x, and then you leave the bracket. But I prefer you multiply out the bracket. Okay? All right. Okay. Yeah?
Would it be 4y over 18 or 418 to the y? 4 over 18 to the y. Would you put the y on the outside of the...
It would not be 4y over 18 anyway. You have to simplify first.
Oh yeah, but just wondering. Did you put the y on the outside?
I would prefer the y on the side for the answer. But simplify first. So you end up with 2 over 9y. Okay? All right. So we've talked about multiplying. So what's naturally the next operation you think? Dividing.
What? No, we didn't.
Okay. Now, we're going to come back to some of it. We haven't done all of this. Okay? Now, can somebody make me really, really, really proud here and remember what is unique about dividing fractions?
It doesn't change.
Well, no, not exactly. But what?
You have to flip it.
So what's unique about it is
Can divide.
that you can't divide fractions.
Oh,
Do you remember that?
simplify them. Yeah.
Okay? Because and y'all were getting to where you're going, but remember, it's you can't divide. What you're going to do is you're going to change to multiply by the, anybody remember the fancy word? Starts with an R. Reciprocal.
I think it's reciprocate.
All I can think was the red thing.
Yeah, I was gonna say radical.
Yeah.
The line.
Multiply by the reciprocal. So here's what's going to happen. So if I have some A over B divided by some C over D, right? I'm just using letters instead of numbers. What operation do I have indicated there? Division with what kind of numbers? Fractions. What do you know about dividing fractions? You can't. So what I have to do is change it to multiply. Come on, guys, listen to this part. Multiply by the reciprocal. So the multiply comes first. The reciprocal comes what? Second. So in other words, the first fraction will not change. What does the division become? Multiplication. And to find the reciprocal of anything, all you do is what? Flip it over. Invert it. Right. So C over D is going to become what? D over C. Which means I then don't have division anymore. I have multiplication. So do I already have some rules for that? Yes. So before you multiply, you simplify, then you multiply straight across. It's always the one following the division symbol. That's why it says by. So it's always the second one.
Take one over two.
Okay? So, I just want to do this though. So what is the reciprocal? Guys, come on. What is the reciprocal of 3 over 4?
4 over 3.
4 over 3. What is the reciprocal of x over 2?
2 over x.
2 over x. What is the reciprocal of 3?
3. Oh, 1 over 3.
Yeah, because 3 is the same thing as 3 over 1, so the reciprocal of it is 1 over 3. If you don't have a fraction, that means what's in the bottom?
1.
A 1. What's the reciprocal of y then?
Y.
1 over y.
You were so.
Right? Because remember, yeah. Because y is y over 1, which then when you flip it over. Okay?
No, it's meant to be A, because you do the one that's
Right. It's always the one, you always take the reciprocal of the one you're dividing by, which is the one that follows the fraction bar. It's the fraction bar that messes with it, right? And the fraction bar is in front of the division symbol. The division symbol is the thing that's messing with it, so it's the one that follows the division symbol.
You know the division symbol?
Yes?
Yes, you know how there's the 1. And then
Yeah.
there's not there's a missing one.
Just a fraction, yeah.
Did you actually know that?
Yep. I probably mentioned it to y'all at some point.
It's on TikTok.
Is it? There you go. Yeah. Because because this symbol was invented later. All division used to be written like that. But then the division symbol was devised later. Wasn't invented from TikTok. Come on, guys. Focus. Come back to me. All right. Let's do an example. 9y over x divided by 3 over x. What operation is indicated? Division. With what kind of numbers? Fractions. Can you divide by fractions? No. So we need to change it to multiply by the reciprocal. So when you do that, will the first fraction ever change?
No.
No. So 9y over x stays the same. What does the division become? Multiplication. And the reciprocal of 3 over x is? X over 3. Okay? Now look, guys. So be careful. Now that I haven't changed it to multiply, I go to the rules for multiply, which says that before I multiply, I must first Simplify. What's the first factor in the numerator? 9. Is there a 9 or anything that has divides with 9? I love the enthusiasm, but okay. 9 and 3 will both divide by 3. So 9 divided by 3 is going to leave a what? 3. 3 divided by itself is going to leave a what? 1 in the bottom. It's 3 divided by 3. There you go. Yeah, you're getting ahead of yourself. What's the next factor in the numerator? Well, there's a y, right? Is there a y anywhere in the bottom? No. What's the next factor in the numerator? Is there an x in the bottom? Yes, exactly another x. So x divided by x turns into a 1. Be careful. X divided by itself is 1. Now have I finished simplifying? So I can multiply how? Straight across. 3y times 1 is simply
3y.
1 times 1 is 1. And 3, wait a minute, and 3y over 1 is just the same as what? 3y, right? Because remember, if you have 1 in the bottom, then it doesn't mean you have a fraction. Okay?
I just feel really weird, like, the question kept going after I took up all my space.
Okay? Right? All right. So here we go. All right. So there are 2 more operations that we need to talk about, but really, when we talk about algebra, we actually usually put those 2 operations together, right? The operations of addition and subtraction we now just call combining. And that's true with fractions as well. So the next operation we're going to look at is we're going to look at combining fractions. Now again, remember, combining fractions just means add or what? Subtract. But sometimes it looks like subtraction, you actually add, etc. So we just put it all together as combine because we use the sign rules, right? Now this one is generally held off last because it is the most complex one. But once you understand how it works, it's not difficult. You just have to remember that anytime you change the operation with fractions, you change the rules, right? Are the rules the same for multiply as they are for divide? No. You have to change but you'd end up changing the division to multiplication, then the rules are the same because you're using the same operation, right? So you cannot decide that something has you can use the same rules for it if it changes operation. Okay? Here we go. So combining fractions. The first thing is...
Combining fractions.
Combining fractions. Thank you. It says combining. All right, here we go. So if you're combining fractions, you must have a common denominator. Remember that? Which part of the fraction is the denominator?
The bottom part.
Bottom part. They have to be identical. If they are not, then you cannot add or subtract them. Right? So, you must have a common denominator. Okay? Guys, come on. If not, you must find the least common denominator, or I think y'all might call it lowest common denominator. It means the same thing. Now, what's important here is that least part. It needs to be the smallest possible thing that you can use. All right? Okay? You must find the least common denominator. Now, there are a million different ways of doing this. I'm going to show you one, and I know that I showed it to you before when we did the number thing. You can like it, love it, hate it, do something different. I don't care as long as you're getting the right answer. I'm fine. But most people don't have any method for this. They just kind of hope for the best. So I'm going to show you something. All right? And what I do is I use upside down division. Do you remember me talking about this before? No, maybe. Now again, you don't have to, but I think it's a very easy way to make it work. Here's the way it works. First step, okay, is list the denominators in a row. Okay? So, right. So say, let's go ahead and get you an example going. Now just, who cares what the bottom is? Because I'm only talking about the denominator. Now I know you already know what the denominator, the LCD is here. Just bear with me. I'm giving you something easy to start with because I want you to just concentrate on the method. So what are my denominators here? 7 and 2. So I'm going to put them in a row. Put an upside down division symbol around them.
What? An upside down division symbol is what is that word?
Upside down, put an upside down, upside down division symbol around them. So in other words, you're just going to put them in a division symbol to hold them together, to know that you're working on them at the same time, right? Okay. Third. So all I did was just put the division symbol, but upside down. Okay. Now, divide out any common factors. Now remember, common factor means anything that will divide evenly into both of them, right? And then the last, so 7 and 2 together. Okay. The last step is to multiply everything outside together. Everything that's outside the division symbol, everything on the outside, you're going to multiply together. Okay?
So like 7 and 2.
If any, because this one is an odd one. Yes, I picked one that you can't really do this way. All right, so we put our 7 and our 2 in our upside down division symbol. And I'm just going to look and see, is there anything that will divide evenly into 7 and 2? No. So is there anything on the outside to multiply together? No. So what we'll do in that case is simply multiply the stuff that's on the inside, which gives me an LCD of what? 14. I just pulled one out of the book, and it just happened to be one that doesn't do any good. Okay? Let's look again. Hate that. All right. So let's look at a few others, though. Say we have 4 and 12. So those are our denominators. Is there anything that will divide evenly into 4 and 12? Yep, they'll both divide by 2. All right, 2 is fine. Now let's divide. 4 divided by 2 is 2. 12 divided by 2 is 6. But don't 2 and 6 have something in common? They'll still divide by 2 as well, won't they?
Sorry. They want others with line things.
They're division symbols.
No, but like, why do you
How?
upside down?
Because it encloses the numbers. Don't worry about the fact that it's upside down. No, because that means multiply. 2 divided by 2 is 1. 6 divided by 2 is 3. Is there anything common to 1 and 3? No. Now, what am I going to do with all the stuff that's on the outside? Multiply it all together. 2 times 2 is 4. Times 1 is 4. Times 3 is 12. So what's the LCD for 4 and 12? 12. Now, that one could have been done a little faster if you had seen, it all come to 112. That's not what I wanted me to do. Because you saw that 2 divided into them, which was perfectly fine. But can you see something bigger? Yeah, they would both divide by 4 originally, right? So 4 divided by 4 is 1. 12 divided by 4 is 3. and you'll still end up with the same answer. So it doesn't matter. If you're comfortable doing division with the bigger numbers, right? Okay, right. This is just if you don't have a common denominator. And a way to get one. Okay?
How do you get the things on the outside?
Okay, so I've shown you this. We're going to use it next time when we look at adding and subtracting fractions. It's such an important process that I want you to see it twice. And you're going to especially see this LCD thing again. Okay? All right.